Hey kids, Mr. Murray here, Mr. Murray's Math Land, and today we are taking a look at cosecant and secant graphs and how to sketch them by hand. Because of course you can take a look on Desmos or your graphing calculator if you want a good, perfect graph of these things. But if you are good at sketching sine and cosine graphs, these are very similar. So let's just take a look at this one here. We're sketching y equals secant of x minus pi over 2 plus pi. Now secant, the secant function is the reciprocal of cosine. So I'm just going to think about this as if I'm graphing this function, but instead of secant, with cosine in its place. So cosine, and this is positive secant, so I'll be thinking about positive cosine, would look like that, starting at a crest, right, and then one complete trough, and then ending at the crest. The amplitude of this is 1. The midline is y equals 2. That's the middle of the graph. The period is 2 pi divided by b, whatever is being multiplied to x. And in this case, that is just 1. So 2 pi. I've not changed the period. No horizontal compression or stretch. And that distance between key points, as I call it, the increment between the key points, is always the period, which is 2 pi, divided up into 4 equal regions. So 2 pi divided by 4, or pi over 2. And now let's get the 5 key points. Now, there has been a phase shift here. On the inside, we have x minus pi over 2. When you set that equal to 0, in solve, you'll get x1 is positive pi over 2. So our next key points will just be found by adding that increment right here onto those. And so when I take pi over 2, that first key point, the starting point of the cycle, and I add pi over 2, it actually works out nicely. I'm going to get pi, add it again, and you're going to get 3 pi over 2, add it again, and you're going to get 2 pi, add it one more time, and you'll get 2.5 pi or 5 pi over 2, whatever you want to call it. So here you have all the key information here, and I'm still going to approach it. Imagine I was graphing a positive cosine with all this information. So on the y-axis, my midline is 2 and my amplitude is 1. So that would be right here, right? There's 2, and so there would be my middle of the graph. And the amplitude is 1, so I would be up, if I were graphing the sinusoidal graph, as high as 3 would be the maximum, and 1 unit below that midline would be at positive 1, so your range would be everything between 1 and 3. Now let's think about the shift here. We have shifted it over to pi over 2, so let's figure out our scale since we have a grid here. Maybe every 2 boxes could be pi over 2, so that's pi over 2. That would be pi, 3 pi over 2, 2 pi. Just barely we're going to fit it in, so seems about right here. There's the first key point, second, third, fourth, and fifth. Pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. Okay, now if I were graphing this as a cosine, and I'm even going to go so far as to do it, but I'm going to do it with a little bit with a dashed line because I'm not really graphing cosine, and you don't have to do this in order to draw these, but it's a nice visual, at least at the beginning here. So remember those key points right here, on the midline, off the midline, on the midline, the alternating. The first one, which happens at pi over 2, at x equals pi over 2, is going to start at the crest, so that would be 1 unit above, right? So it would be right there. X2 would be at pi, and that will be on the midline. 3 pi over 2 is going to be 1 unit below the midline. 2 pi is going to be back on the midline, and at 5 pi over 2, we're going to be back above it. Now, if I were graphing cosine, I would be drawing this. I'm going to draw it with kind of a dashed line here. It's not really the graph I'm drawing. I'm not really done. But that would be it, and I would be done. But here's the only difference, is that any place where cosine is 0, those would be the places where you're on the midline now. That would be places where its reciprocal, secant, would be undefined. So those spots where we're on the midline, x2 and x4, are where secant's undefined. That's going to be a vertical asymptote. So I'm going to sketch right at those two spots. I'm going to sketch two vertical asymptotes, and these spots that are at the peaks here, that is still going to be there, right? This would be, normally on the parent function, where cosine is 1, the reciprocal of 1 is still 1, so you're going to have that same value. But all these values in between here, there to there, when you take the reciprocal of those kinds of values, you're now going to get things that are bigger than 3. So that's all I'm really going to do, is I'm basically just going to flip these up here. And in the middle here, this complete trough, right at that minimum, now that's going to flip and you get these kind of curves which are between the two asymptotes. So if you were to keep scrolling down, it would really look like a test tube, because it's not going to go any wider. And then on the far right, x5 there, we're going to have that right at that key point. And then flip that up. And that's totally fine with me if you want to leave that as your graph. Some people like to then erase the dotted line so you don't really see that. Some people leave it there, and I'm fine if you do. But that's what you got. That's one complete cycle of a secant graph. And of course, the graph keeps going, in all directions. There's going to be these asymptotes, and it's going to alternate with an upwards kind of curve, a downward curve, upward, etc., etc. But there's one complete cycle of it. So let's take a look at a cosecant example, and you should be pretty good then. So I'm graphing a negative cosecant, so I'm going to view this as its reciprocal function, which is negative sine. So think about what negative sine looks like. And that's why I said if you're good with the sine and cosine, then you already have all you need to really get going. It's a slight tweak to that. But if you are hazy with some of these concepts, you might have to look back at them rather than try to learn all this at once. So that's what a negative sine looks like, right? Starting on the midline, then one trough and one crest. Our amplitude would be 5. Our midline, middle of the graph, would be y equals 1. Our period would be 2 pi divided by that 2 that's being multiplied to x, and would make that a horizontal compression, having a period of pi now. And that distance between key points, the increment, would be the period of pi divided by 4. To get x1 here, you do have a phase shift, but you also have that coefficient of 2, so just be careful. When you set that equal to 0, you're going to get 2x equals negative pi over 2, divide by 2, and your first key point, x1, the start of the cycle, is going to be at negative pi over 4. So again, these numbers kind of worked out nicely, that the increment is pi over 4, and the key point, the first one, is at negative pi over 4, so you've got common denominators already. And x2 is going to be at 0, x3 is going to be at pi over 4, x4 is going to be at 2 pi over 4, or pi over 2, and x5 is going to be at 3 pi over 4. Distance from there to there being pi units, right, the whole period. And now let's worry about this scale and spreading it out. So let's see, on the y-axis, seems pretty straightforward. The midline is 1. Again, you don't have to draw that dashed line. I like to just to give me a center there. The amplitude is 5, so we're going to go as high as 6, right? 2, 3, 4, 5, 6. And you're going to go as low as 5 units below that midline, so down to negative 4. That would be your max and your min of your sinusoidal graph. And now we're going to sketch this graph. Let's look at those x key points. Negative pi over 4, so seems like every 2 boxes should probably be okay, and negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4. Seems good enough. So that will be negative pi over 4. There's 0, don't forget about that. Pi over 4, pi over 2, and 3 pi over 4. Okay, so that first key point here would be right on the midline, right? So at negative pi over 4, you would be right on the midline of pi value of 1. At 0, you would be at the bottom of the trough. So at 0, we're going to be at negative 4. Pi over 4, you're going to be on the midline. At pi over 2, you're going to be at a height of 6, right? The maximum there. And at 3 pi over 4, back on the midline. And there's your complete negative sign cycle. Right, so I sketched it with that faint dotted line, which I'm going to erase, or you can leave, but at least it's not too dark right now. And similar to the secant, the same idea that any points that are on the midline, that's where sine is 0. So these 3 spots, in this case x1, x3, and x5, those will be places where cosecant is undefined. And if you don't believe it, of course, go ahead and plug negative pi over 4 into here, and you'll get a 0 on the inside, and the cosecant of 0 is undefined. So all 3 of these spots are places where this graph is going to be undefined, so we're going to sketch a vertical asymptote. We're going to have those same kind of curves, those same, test tube looking curves boxed in by those vertical asymptotes in between, the first and third key point. Right there's the bottom of the trough. Well, that will now be the maximum of this curve. That gets flipped downward. There you go. In between x3 and x5, at this crest here, that will actually be the minimum of this curve when you flip that up. And there we go. I'm just going to take away that in the middle, which you don't have to do, but I kind of like to. And see, pretty simple. So everything's pretty much the same as graphing sine and cosine, just with a couple tweaks. So if you have any questions, just let me know. Hang in there and work hard. Take it easy.